So for us, we've developed this platform where we're able to build, fit for purpose, disease-specific tissues in any sort of geometry that you could think of, in different well plate formats, and then really design the functional readouts specific to the tissues themselves. So tissue and organ scale specifically, right? Not just on the molecular and cellular level, where we're looking at these tissue level functions. So you can see these different tissues. I'll play some of these videos here. We're able to build a wide variety of geometric complexity and also cellular and compositional complexity tissues. And then so we'll take, any sort of human cells and ACM matrix, start with sort of computational design tissue architecture. And we publish this in some high profile journals, and, take these and directly 3D bioprint them using these native biomaterials. And this is really what enables, I think, these NAMs for the specific functions that we're looking out of them. And then we'll take our robotic biofabrication. We have the ability to control deposition any way we want it. And then really design, as I said, the analytical capabilities and physiological readouts specific to these three-dimensional tissues to this systemic level information. And I think some of the highlights is really we're able to create the native tissue structure, right? So at multiple length scales, we're able to deposit these, cells and cardiac tissues at native-like cell density and alignment. And you'll see with some of the data I'll show is that we can build these healthy cardiac tissues and design the tissue specific to the imaging modality, the data that we want to collect. We want to demonstrate responsiveness to test compounds, tool compounds, and then eventually we can apply this toward disease cardiac tissues, whether it's mimicking the composition or mimicking the disease structure phenotypes that are demonstrated in these disease tissues, and then be able to reproduce a model of that disease phenotype. So here are some of the tissues that we've shown that we can fabricate, and this is just a small sample of what we can create. And you can see from some of these more two-dimensional, 2.5D structures to true 3D, some of these ventricular structures. And I think being able to start to create some of these ventricular level readouts where you not only have contractility readouts, but you start to get, volume, pressure, ejection fraction type information that then starts to get us closer to, collecting the data that we might want.